We are now at question 10 of the CXC CSEC May 2014 General Paper 2 exam video solution. And in this question 10, we are given this circle, center O, and the line BC is a tangent to the circle here. And we are told that the angle CBD is 42 degrees, angle CBD is 42 degrees. That's the angle between this chord and the tangent here. And we're also told that the angle OBE is 20 degrees. That's this angle right here. Angle OBE is 20 degrees. And then we're asked a series of questions and we have to give reasons for our answers. And the first part wants us to calculate angle BOE. That's angle BOE. That's this angle right here. Let's call that angle theta and mark that angle theta on the diagram, and that's it. Now, this side is a radius and this side also is a radius because this is the center of the circle. Then the line out to the circumference here is a radius, and this line out to the circumference also is a radius. And therefore, in this triangle here, these two sides are equal, and so this triangle is an isosceles triangle. So let's write that, and that is it. Triangle BOE is an isosceles triangle, and therefore the two base angles here in this isosceles triangle are equal, and so this angle here, angle BEO, is equal to 20 degrees because the base angles in an isosceles triangle are equal. And so we can show that 20-degree angle on the diagram. That's it here. And we can now consider the fact that the total angles in this triangle is 180 degrees. And that's the basis on which we can find the angle theta. And so this is it. Total angles in triangle BOE is 180 degrees. And therefore, 2 times 20 degrees, that's the sum of these two angles, plus the theta here, plus theta, is equal to 180 degrees. And the 2 times 20 degrees here is 40 degrees. And so to find theta, we subtract 40 degrees from both sides. And this is it. Theta is equal to 180 degrees minus 40 degrees. And so theta is 140 degrees. And therefore, we have found the angle that we wanted. Angle BOE is 140 degrees. And that's the answer for part 1. Part 2 now wants us to find angle OED. Angle OED. That's this angle right here. Let's call that angle alpha and mark that angle alpha on the diagram. And that is it. Now, alpha plus 20 degrees is the sum of the angles between these two sides. And the angle between these two sides is subtended by this chord. And this chord is making an angle of 42 degrees with the tangent. And we know that the angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment of the circle. And therefore, alpha plus 20 degrees will be equal to the 42 degrees right here. And we can show that. And this is it. Angle BED, that's it. Angle BED, that's the total angle across here, will be equal to angle DBC. Angle DBC. And that angle DBC is 42 degrees. And therefore, angle BED is equal to 42 degrees. And that is because the angle between a tangent, which is BC in this case, and the chord BD is equal to the angle subtended by the chord BD, the angle subtended by this chord BD at the circumference E in the alternate segment of the circle. That angle is equal to 42 degrees. And if we shade out this information, we can make that clear. And that is it. The angle here between this chord and this tangent is 42 degrees. And therefore, this chord will subtend the same 42 degrees at the circumference in this segment of the circle. And therefore, the angle between these two sides is 42 degrees. And if we remove that shading, we see that that 42 degrees comprise of alpha and 20 degrees. And therefore, 20 degrees plus alpha is equal to 42 degrees. And so, alpha is equal to 22 degrees. 20 degrees plus alpha is equal to 42 degrees, and if we subtract 20 degrees from both sides, we see that alpha is 22 degrees. and therefore the angle that we want, angle OED, is 22 degrees, and that's the answer for that part. Part 3 wants us now to find the angle BFE. That's angle BFE. That's the angle right here. Let's call that angle beta, and let's mark that angle beta on the diagram. And so now we are trying to find this angle beta. Now we must observe that beta is one of the angles in this cyclic quadrilateral, and this is it. BDEF is a cyclic quadrilateral because it is a quadrilateral inside the circle such that the 4 vertices of this quadrilateral are on the circumference of the circle. And so BDEF is a cyclic quadrilateral. And the opposite angles of a cyclic quadrilateral are supplementary, meaning they add up to 180 degrees. So let us show that quadrilateral in the diagram. And this is it. That's our cyclic quadrilateral. And this angle beta and the angle at D here will add up to 180 degrees. And that is it. Angle BDE, that's this angle here, and angle BFE will add up to 180 degrees because, as I've said, the opposite angles in the cyclic quadrilateral add up to 180 degrees. They are supplementary. And so if we call this angle theta, it means that theta plus beta will be equal to 180 degrees. And that is because the opposite angles in the cyclic quadrilateral are supplementary. Therefore, beta will be equal to 180 degrees minus theta. And so now we need to find the angle theta. But let's move the shading from the diagram so we can see the rest of it. And this is it. Now, theta is being subtended by this chord BE. And BE is subtending an angle of 140 degrees at the center of the circle. And we know that the angle subtended by a chord at the circumference is half the angle that the same chord subtends at the center. And let's show the calculation here. Theta will be equal to half of 140 degrees, which works out to be 70 degrees. And this is because the angle subtended by a chord at the circumference is half the angle that it subtends at the center. Theta is 70 degrees because this 140 degrees is subtended by this chord at the center, and so the same chord subtends half as much at the circumference. And therefore, theta, as we said, is 70 degrees. Now that we know that theta is 70 degrees, we can proceed to calculate beta by subtracting that 70 degrees from 180 degrees. And when we do that calculation, beta comes out to be 110 degrees. And therefore, the angle BFE is 110 degrees. And that's the answer for that part of the question. Let's move down now to part B. Now, part B gives us this diagram, and we are told that P, Q, and R are 3 ports, and the 3 ports are on horizontal ground. Now, this line with the N here represents the north direction, and therefore this is a plan view of the points P, Q, and R. And we are told that PQ is 80 kilometers, QR is 100 kilometers, and the angle PQR is 54 degrees. And that information is shown on the diagram. We are also told that the bearing of R from Q is 066 degrees. And the bearing of R from Q is a clockwise angle from the north line at Q, which is a from position, to the line joining Q to R. So let's show that bearing angle of 066 degrees on the diagram. And this is it. This is the bearing of R from Q. Bearing must be measured at the from position, and the bearing of R from Q is the bearing at the from position, which is the clockwise angle from the north line at the from position to the line joining Q to R. And so this angle, 066 degrees, is the bearing of R from Q. The first part of this question wants us to calculate the bearing now of P from Q. And so in this case, Q is a from position, and so this bearing must be measured at the from position Q. And this is a from position Q. and we already have the north line at Q, and therefore the bearing of P from Q is a clockwise angle here from the north line to the line joining Q to P. So let's call that angle theta and show that bearing angle on the diagram. And that's it. This is the bearing of P from Q. It is a clockwise angle from the north line to the line joining Q to P. Now this angle theta will be equal to the sum of these two angles. That is the 066 degrees here and the 54 degrees here. And so theta is simply equal to 066 degrees plus 54 degrees. And when we do that calculation, the result is 120 degrees. That is, the bearing of P from Q is 120 degrees. Part 2 now wants us to calculate the distance PR. That's the distance right here. And we have to work in this triangle to calculate this distance PR. But this triangle is not a right angle triangle, and therefore we have to use either the sine rule or the cosine rule to calculate the distance PR. And this is a typical case for the use of the cosine rule because we have two sides and an angle between. The sine rule cannot be used here because to use the sine rule we must have a pair of known side and opposite angle, and that is not the case here. And so to do this calculation we must use the cosine rule. But let's look back at the cosine rule, and this is it. When we have two sides and an angle between, the opposite side of that angle squared is equal to this side squared plus this side squared, that's it, minus 2 times the product of the two sides multiplied by the cosine of the angle between the two sides. That is the cosine rule. And if we apply the cosine rule, we see that PR squared will be equal to this side squared plus this side squared, that is it, 100 squared plus 80 squared, minus 2 times this side times this side, that is 2 times 100 times 80, multiplied by the cosine of the angle between those two sides, which is the cosine of 54. Let's do that again. PR squared is equal to this side squared plus this side squared minus 2 times this side times this side multiplied by the cosine of the angle between these two sides. And so when we do our calculation with a calculator, this works out to be 6,995.436. And to find PR now, we take the square root of both sides, and this is it. And when we do that calculation, PR comes out to be 83.64 kilometers, correct to 2 decimal places. And that's the answer for that part. Let's move down now to part 3. Now what we have so far is that PR is 83.64 kilometers. So let's put that on the diagram. And the next part now wants us to calculate angle QPR. That is angle QPR. That's this angle right here. Let's call that angle alpha and show that angle alpha on the diagram. And so this angle alpha is angle QPR. And so we are working in this triangle again, and we have to use the sine rule or the cosine rule. And we are now able to use the sine rule because we have a pair of angle and side opposite each other. Once we have a known side and angle opposite each other in a triangle, we can use the sine rule. And so to do this calculation to find alpha, we shall be using the sine rule. And this is the sine rule. The sine of an angle divided by its opposite side is equal to the sine of another angle divided by its opposite side. And this is it. And we are using the sine rule in this form instead of in the reciprocal form because we are trying to find an angle. So let's show the calculation for this triangle. And this is it. The sine of alpha divided by 100, that is the sine of this angle alpha divided by the side opposite to alpha, is equal to the sine of 54 degrees divided by 83.64. That is the sine of this 54 degrees divided by the side opposite, which is 83.64. And let's repeat that. Sine of alpha divided by 100 is equal to sine of 54 divided by 83.64. And to make alpha the subject, we can first multiply the 100 across this side. And this is it. Sine of alpha will be equal to 100 multiplied by the sine of 54 degrees divided by 83.6. And if sine of alpha is equal to this expression, then it means that alpha is equal to sine to the minus 1 of this expression. To find the angle, we have to take the inverse sine. And when we do this calculation, our result is 75 degrees to the nearest degree, as we were asked to give our answer to the nearest degree. And so alpha is 75 degrees. And that's our answer for this part of the question. And that's the end of question 10. And we'll do question 11 in our next video. See you then.